Hi, I'm Larry Puckett, the DCC guy. Today we're going to take a look at a new signaling system, the one that I've been telling you about now for several months, and I'm going to be installing that today on the new module. So stick around and take a look at how easily you can set up signaling on your model railroad. Let's get started with the video. Hit that little red subscribe button, and when the little bell comes up, click on it and click all. What I'm going to be doing today is really two parts. I'm going to begin by going over some of the details about this new signaling circuit board and detector combination. And yes, it is a combined circuit board that serves both as a detector and the logic for handling your signals. But we'll get to that in a minute. So what I'm going to do first then, as I said, is go over the specifications for this board. I'll go over some of the details about how it works. And then after going through all of that, I'll take you over to the module and I'll crawl around underneath there and install the circuit boards. Now, fortunately, I don't have to do the wiring because back in video 392, I showed you how to set that up. I thought ahead. I was smart for a change and went ahead and installed the wiring and got it ready when I was going to install these circuit boards. Now, for those of you who I know are not going to want to sit through and listen to the specifications and an overview of how this detector and signal board works, I'm going to put a timestamp right down here below me. And you can go ahead and scroll forward to that point in the video, and that's the point where we will start installing the detectors and the signals on the layout. And then at a later date, if you're interested, you can come back and you'll be able to watch that part of the video. Now also, for those of you who are interested, I have already put a copy of the instructions for this signal detector board on my personal website, and it is larrypuckett.wordpress.com. And I'll add that to the description so you'll be able to find it at a later date. I'll also put in the description a link to where you can purchase these signal boards. They're available through eBay and also through Dispatch Hobbies in Rochester, New York. Let's go ahead and get started with that overview of the circuit board. And for that, I'm going to bring you in here to the top of the workbench where I've got one of them laid out for you to look at. Okay, so here is the circuit board. Let's start with an overview of the specifications. Now, the device comes with terminals on each end right here for the red, yellow, and green LED or light bulb connections. So you'll be able to do that right away. You can just screw those, put those wires in, screw it down, and you're ready to go. Now right here in the center, you see this device? This is a current transformer, and your power from your DCC feed comes in here, goes through these wires, and goes back out here. And when you've got a locomotive on the track or a detectable wheel set, it will induce a current in this transformer that the logic in this board will use in order to set the signals properly. Now, another feature that's available here, I said these will work with either LEDs or light bulb type displays. And right here is a jumper that allows you to select the signal type. And you have to make sure that if you're using LEDs, that it is set for LEDs. If it's set for bulbs, it's probably a 12-volt outlet. And down here, it's much lower. So you got to be careful. Make sure that that jumper is set for LEDs before you hook up your LEDs to it. Now, a couple of other neat features here. You've got, as I said, the screw terminal for your DCC feed to come in and go back out into the track. And we'll look at that hookup in a minute. There is a set of connectors here that are used for approach logic so that you can set it up so that your yellow light will come on if the block ahead is occupied. So that's possible to set up. There's an I/O setup right here, and that's in case you need to use two different power supplies. Basically, you can power this off of one 5 to 12 volt DC power supply, and it can run a whole bunch of these. Matter of fact, it's recommended that you only use one DC supply for all of your boards, because then you won't have to do this more complicated I/O wiring. Okay, and right here is your DC power supply. So it says 5 to 15 volts. So pretty liberal as far as that goes for what you can use to supply it. Let's go over some of the specifications, and I'll show you this in a diagram here. And as I said, it runs on 5 to 15 volts DC current coming in that you supply separately. At that current, at 5 volts, it uses about 17 milliamps. At 15 volts, it's only using about 66 milliamps. So you can power a lot of these with a 1 amp power supply if your maximum is going to be 66 milliamps. Okay, what else? In LED mode, it has a constant power source, and that means that you can use your LED signals without resistors on them. And matter of fact, he suggests that if you purchase the ones from China that I am going to show you, he recommends that you cut the resistor off on that common lead, and that'll give you a much brighter LED. Now, as I said earlier, I believe it can handle occupancy status, whether or not a locomotive or a detected wheel set is on the track ahead of you. And if that turnout ahead of you is set against you, it will give you a red signal to warn you about that, to stop your locomotive. The sensitivity of the unit can be changed and customize the sensitivity of the circuit board for detection, and it can handle up to 9 amps continuous current through the circuit board. So it's a very robust one at that. Now, what I want to do now is show you some diagrams of the way that this basic setup is done. So this one right here that I have up shows you how you would set the signaling up for a single tracked main line. So each one of those horizontal lines there is a rail, not the track. So it's a rail A and a rail B. So you can see that he's indicated cuts be made in one of those rails to isolate it as a detection block. And then power goes in from your DCC supply at the lower right, goes in through the detector, comes out, and is fed to that rail that's been isolated. The other rail is supplied directly by your DCC supply, as shown also on the right side of that diagram. And you can see that the signals have been wired in to the screw terminals at each end for the red, the green, and the yellow LEDs, plus the common. So it uses a positive common wiring scheme. Okay, so make sure that if you purchase LEDs for use with this, that they are wired that way. And what else have we got down here? You can see where you attach the power supply and adjust the sensitivity. So it's a very, very easy system to set up. All you have to do is cut your rails, cut gaps in your rail there, add your signals, hook up the circuit board, and you're ready to go. And I would refer you back to video 392, where I showed you how to wire up your layout with DCC to be able to do block occupancy detection and set up signals. So make sure you go back and take a look at that if you have a question. Okay, let's look at the next one of these. Okay, this particular diagram shows you how you set up approach wiring. And remember, approach wiring simply means that if the block ahead of the one that you're entering is also occupied, it will give you a yellow signal. Otherwise, it'll be a green signal for you to enter that block there. And it's very straightforward, as you can see from this diagram. All you have to do is wire the approach in and the approach out together on the two boards, and it will automatically take care of that for you. So, a nice feature to be able to have. And as I said, you can also set this up to warn you when turnouts are set against you in the block, because you want to be careful about flying into a block ahead of you at a high rate of speed and find out that a turnout at a crossover is thrown against you and you derail when you try to go through there at 60 miles an hour. So as you can see from this diagram, it's fairly straightforward. You run it through the additional switch machine contacts on a Tortoise or an IP Digital or various other switch machines out there, and run that in to where that shows the turnout in on the diagram. So that is the center screw terminal here. It says turnout in right on the circuit board. So that's one nice feature about this. All of the various connections on this circuit board are labeled. So you'll be able to take a look at the circuit board as well as the diagrams and get your wiring done correctly. Let's take a look at this putting it all together diagram, because that has a lot in here. And it looks very much like the wiring that I have on the module in Alexander. And that's what I'll be doing later on, not in this video, but in one in the future when we get to a little bit more complex wiring example. So you can see all of the different signals that you can add in a given block that is very complex. So he's provided a very good demonstration of how you can wire this up. Now, let's look at how the wiring works on that. So he's even gone in here and given you a very good example of how to wire up that more complex set of connections. And as I said, in a future video, I'm going to come back and I will add all of these additional signals and all of this additional wiring to the layout. We'll walk through that and I'll show you how to do a much more complex design. Okay, so at this point, what I'm going to do is I'm going to connect two of these to the layout where I've prepared the wiring already, so that we're going to operate on a north-south main line, and I'm going to observe right-hand running rule, and that's what the Southern Railway observed on the double-track main line between Washington, D.C. and Atlanta. The Southern Railway had a right-hand running rule, and you could only cross into the other track under special orders. So that's what I'm going to go with, and that greatly simplifies things, because it means each track can be wired as an individual block, and we only have to set up one block detector in each and a pair of signals for each. And for those signals, I'm going to be using this guy here. So these are the ones that I got off of eBay from China, and they're very easy to find. Just look up HO railroad signals on eBay and they'll come up. I would enter the site for you, but you never know from one day to the next whether or not the same company is going to be selling these on eBay. So you just have to go there, do a search yourself for HO model railroad signals, and you'll get a bunch of these things coming up. So it's a fairly nice little signal. I've shown you this in a number of examples in the past and on the old model railroad, and they're already pre-wired. They come with this resistor built in. You probably should remove that resistor before you connect these to the circuit board, because otherwise you're going to get a dimmer output from your LEDs. This resistor is going to do its job, cut the voltage down. Let's go over to the layout, drill some holes, install the signals here, and wire up the signal board underneath the layout, and we'll be ready to give it a test drive. So let's get over there. Okay, now the first thing we're going to want to do is to mount our signals. And for that, I simply placed a piece of scrap leftover foam road bed right here next to the track, and drilled a hole right on down through there, big enough for the wires to go down through. And the real problem, though, is how do you get these little bitty skinny wires to go down through that hole? Well, there's a trick, and I'm going to share with you an age-old trick for doing that kind of thing. Now, any piece of tubing will work. I just happen to have this piece of heat shrink tubing, and it's just the right size. I drilled the hole for the tubing, so that's going to go right on down through there. Okay, so I'm going to slide these little wires one at a time down into the tube, heat shrink tubing, like so. And one more here, like so. You have to stagger them because they're not going to fit otherwise. And then finally the common wire. Okay, So I'm going to shove some in there. And then I'm going to take a piece, a very small piece, of my blue masking tape. And I'm just going to fold that around the heat shrink tubing and those wires. So that's what we have in the end. Now, take that, feed the heat shrink tubing right on down through there. Let me get it from underneath and pull it through. And if you don't have too much sticking out to the sides, let me do that. It's going to come right on through, and it's going to take those little skinny wires with it. Push it on down onto the base. So I've got that out of there. I've got my little wires installed. I just have to get that, there it is, to slide into place. And there we have it. So, real simple. Now have the first of the signals at the south end of the module all ready to go. So this is northbound. The other track over here is southbound. So now I'm going to go up to the other end and repeat that procedure for the entry to the southbound block, which is up that way. And I'm not going to do that in front of the camera. It's just the same process as right here. And as soon as we're finished with that, we'll attach the signals to the board, get everything wired up, and be ready to test it. Okay, here we are under the layout, and you can see right here where the wires from the signal head up on top of the layout come down through. And then I've added some extensions here because I needed to move some things around. I couldn't work too well over on that side where I originally wanted to because of that switch machine right there being in the way. Okay, so what do we have over here? What I've done is put in a terminal block. And these are very useful items to install on your model railroad. It allows you to bring in short wires, connect them to the screws on these blocks, and then it feeds through. And then I've connected another 4-conductor wire here to carry this through, the connection through to the detector at a central location. And I'll show you more uses of that. Now, I will say I got this 4-position terminal block and some others that I'll show you today. I bought those several years ago from All Electronics. All Electronics is no longer in business, so you can probably get these off of Amazon. You can probably find these on eBay. You can probably find these through the company that replaced All Electronics, started by their employees. And I will put I'll put a link to that in the description, or I'll put the URL in the description. And these are just terminal blocks, screw terminal blocks. And you can get these. You can get the European kind that are white plastic. They do the same job. So I've got the 4 wires coming in. They're color-coded, red, yellow, green, and black. The black is the common, and each one of these colored wires corresponds to the color of the LED that it controls. Now, so I've got that here located here, and then I've got this wire. You'll note I've used a here it is. I've used a cable clamp here. This, I think, is a 1/4-inch cable clamp. You can find these things at Lowe's, Home Depot, again, Amazon, eBay. Folks, anytime you need something and I haven't given you a source for it, look it up on Amazon or eBay. It's very easy. All you have to do is enter it into the search box, hit the search button, and it'll come up with lots of examples. So anytime you're looking for something, go there and do a simple search instead of asking me where I can get these things, because that's where I get most of my stuff. Now you can see this connection here, this black wire, and again, another cable clamp located here to hold it in position, and then the connection and the red and the black wire right here. Now that is my 12-volt DC power supply wire. Okay, and I've got the red and the black wires. They're running forward up through here, and I'll show you where those go because they are going to provide a lot of power for different devices here on the layout. Okay, here we are. I have carried the two wires, the red and the black wires, through here, and I've taken this 3-position terminal block and created a connection for all of my 12-volt devices. Now there's a wire that comes in right here and goes to here, and that is used to power the control panel that I built a few weeks ago. So that's powered off of this 12-volt DC power supply. And then I have 2 more wires, these here, and then they go to this detector board here. And you can see right here, this is where that wire comes in from the signals at the other end of the module. And then I got those run into the terminal block here, to the screw terminal block here, for the 4 colored LEDs and the common wire here. And those are all indicated on the board. Now let me point out, people are going to ask about the cost of this, so I'll tell you. He's charging $25 for these boards. Now let me point out that just for the NCE BD20 detector, which is basically this part of the circuit here, that alone sells from anywhere from about $16 to $20-some. So he's selling this whole board for $25. You've got the detector and a full logic system built in for $25. So it's really a pretty good deal. Okay, so let's go on. So we've got the 4 wires coming in from the signals above the layout there. This wire here comes in from the power bus, and it goes up to this connection, and it goes through the little transformer here, detector, and then from there it goes up to the detection wire here. Now, I'm not going to go through all of that wiring because I explained all that back in video 392, I believe it was, where I showed you how I did the wiring for all of this. So that was covered in another video. If you have questions about how it's wired, go back to that. Okay? So in other words, the power comes in here and then goes out here and up to the truck feeds. And those are the connections right here. There's a terminal block here for power. And you can find that in the instructions, and I covered it in the beginning of this video. Let's see, what else have we got? Okay, over here, we've got our plus and our minus 12 volts coming in to power the board. And again, this can be anything from 5 to 15 volts DC. So check that out. Now, what else is there? That's it on this installation as far as that goes. Down the road, I will be adding a turnout indicator connection here so that anytime a switch on the active track is thrown against you, it'll give you a warning, a red signal. So I'll be adding that in the future and some other things. So for right now, I'm just doing the very basic setup for you. Okay, so that's it. Now that's all there is to it. Let's go up on top of the layout and we'll take a look at how this operates. Okay, here we are at the north end of the module. I've got the power turned on both to the layout and to the 12-volt power supply. So we've got a nice green indicator. So this is what an engineer in a locomotive headed down that southbound track coming into the block would see. He's got a green light indicating that he can go right on in and not have anything in his way. Okay, let me bring up that locomotive idling back there in the background. We'll bring it up. Now watch what happens as he crosses and comes onto the southbound main. We suddenly get a red light. The detector has detected that train in the block and has given a red light indication. And that tells the locomotive engineer to stop, that he cannot proceed into the block that it is occupied. Okay, now let me get him back out of the way and I'll show you something else. Let's move him back down off of the truck, and you'll see as soon as he crosses that switch and clears it, we have a nice green indicator again. What about this caboose right here? Now this is one of those lit cabooses that I showed you how to do in a previous video several years ago. And what I'm going to do is activate that crossover. Now this is a lit caboose. It's taking power, so the detector will detect it. So let's move it across the crossover and into the southbound main. So you can see as soon as he crossed that gap here, we got a red indicator. And again, that would tell the engineer of an approaching locomotive that there is something blocking the track on that southbound main, and he has to stop until the track clears and he gets a green signal. And the same is true at the far end of the layout. I have the other signal that I showed you how to set up earlier in the video, and it protects the northbound main in the same way. So we've got the southbound main and the northbound main protected. Now, this is for a double track. For a single track situation, you would have both indicators on opposite ends of the block on the same track. So you'd have the southbound and the northbound indicators. The detector has two pairs or two sets of outlets for the signals. So all you have to do is wire them up to, he's got it marked as east and west signals. It could be north and south, whatever. In this case, I have this wired up as two separate single track lines through here. Okay, so that's how this works. It's a very simple, straightforward set of signals. It's the simplest design that you could probably install for ABS, and it's what I'm going to be using here. Now, it may not fully replicate what was used by the railroads at any given time. And so if you're looking for absolute prototype accuracy, you're going to have to go and pay more money and get a much more complicated logic and signaling system. And I'll leave that up to you to decide on and to start looking for. But for now, this is a very simple system. Now, at a later date, as I've said before, I will be installing the connections to the various crossovers to give me a red warning if a turnout is thrown. Just like I showed you with the car, it will give you a red warning. So when a turnout is thrown within the block against the movement of a locomotive through here or a train through there, it'll give you a red signal. So that will be for a future video. And also, I will be adding, as soon as I get a couple of more modules built to connect more track at each end, I will add the approach lighting as well. So that would give you a yellow warning if the block ahead of you was occupied. So those are a couple of things that we can look forward to doing down the road to add in a little bit more prototype accuracy to this somewhat simplistic system. And again, take a look at the instruction sheet that I have put on my website, larrypuckett.wordpress.com, and I've put that link in the description as well. And you can download a copy of those instructions and look and see how complex a system you can actually create using these circuit boards from Hyperfokus. And again, if you want to purchase these or get a little bit more information, go to eBay and just look up Hyperfokus, Hyperfokus, and you can order those directly off of that eBay site. So take a look at that, take a look at the instructions, and see if that's going to fit the operations of your model railroad. Well, that's it for now. So I'm going to start working again with the controller for the ESU cab control system. Hopefully by Friday, I'll have a deeper dive into how you can use this throttle on your model railroad. So come on back for that video, hopefully on Friday. I'm not promising anything anymore because it seems like more and more things just keep cropping up and getting in the way of me getting things out on time, like this video right here. So in the meantime, have a great weekend, what's left of it, and a great week. And I'll see you hopefully on Friday, this time with additional information on the ESU throttle. Bye now.